Have you ever thought about the factors affecting ionization enthalpy? You might even wonder why one should ever think about these factors affecting ionization enthalpy. It is because if you remember the factors, what are the factors that affect ionization enthalpy? You can easily sort out the questions. You can easily arrange the given elements according to their increasing or decreasing ionization enthalpy as per what is asked in the question paper. Or you may be asked to give the reason as to why the ionization enthalpy of one element is less than another element when we expect it to be the other way. So, in this video, we are going to discuss those factors. Hello, everybody. I am Anandavali from Guidancee Education Channel. I welcome you all to this new video from Guidancee Education Channel. We are continuing class 11 chemistry, classification of elements and periodicity of properties. Under that, we are discussing ionization enthalpy. We will discuss factors affecting ionization enthalpy. This is part 7 in this series. Before we go into the details, please watch the video completely and subscribe, like and leave your feedbacks as comments in the comment box below. Thank you very much. Factors governing ionization enthalpy. You may not be asked to state the factors which govern ionization enthalpy, but you will have to apply this knowledge in order to answer a question. It is the combined effect of these various factors which decide the ionization enthalpy for a particular element. I will state these factors and then explain them one by one. First one, nuclear charge. Nuclear charge, as you know, is the number of protons present in the nucleus. Second one, atomic size. That is atomic radius. Third one, penetration effect of electrons. By penetration, we mean the closeness or nearness of the electron to its nucleus. Closer or nearer the electron to the nucleus, we say the penetration of that electron to the nucleus is more. You already know electrons in an energy level are distributed in the orbitals named as S, P, D and F. The nearness or closeness of these orbitals to the nucleus is in the order S greater than P greater than D greater than F. So the penetration of the electrons in the S orbital will be greater than that present in the P orbital, greater than that present in D orbital, and then greater than those present in the F orbital. That is, the penetration effect decreases from S to F in this given order, because S is the closest orbital and F is the farthest. Fourth one, screening effect of inner shell electrons. You are already familiar with this term. In multi-electron atoms, the inner electrons will have repulsive effect on the outermost shell electrons, and due to this, the nuclear effect on the outermost electrons will be much reduced. This is known as screening effect of inner shell electrons. The screening effect of inner shell electrons also decide the ionization enthalpy. Fifth one, effect of half-filled and fully filled orbital. You have already learned that half-filled and fully filled outermost shells will provide the atom more stability than others. Now let us see how these factors affect ionization enthalpy. First one, nuclear charge. Let us take the example of the second period elements. The elements with their corresponding atomic number and ionization enthalpy are shown there. With the exception of one or two, in general we can say the ionization enthalpy goes on increasing with increase in atomic number, that is across the period. That is, increase in nuclear charge. The values are in kilojoules per mole. The exceptions are beryllium and boron, Nitrogen and oxygen. What is the reason for the general increase in the ionization enthalpy with increase in nuclear charge? As the nuclear charge increases, the nuclear effect, that is the attractive effect on the outermost loosely bound electrons, go on increasing. In the case of elements belonging to the same period, the added electron is to the same outermost shell, but the attractive effect by the nucleus overweighs the repulsive effect of the electrons. Therefore, it becomes more difficult to remove the loosely bound electron from the atom. So, ionization enthalpy increases across the period. Let us consider the second one. In order to explain this, we will consider the first group elements. Atomic size goes on increasing down the group because the number of shells go on increasing. The atomic number also goes on increasing across the period. When the atomic number increases, the number of shells is not increasing. The size of the atom decreases. But down the group, the atomic number increases, the number of shells also increase, so atomic size increases. From the values of ionization enthalpy given here, you can easily understand as the atomic size increases, ionization enthalpy decreases. That is, it becomes easier to remove the most loosely bound electron from the valence shell. Down the group, though the atomic number or the nuclear charge is increasing, there is also shielding effect offered by the inner electrons. So the effective nuclear charge experienced by the outermost electrons becomes much less. Therefore, ionization enthalpy decreases down the group. So, when atomic size decreases, ionization enthalpy increases. When atomic size increases, ionization enthalpy decreases. We will see examples to understand how penetration effect affects ionization enthalpy. Magnesium with atomic number 12. As per electron distribution, the outermost orbital is the s orbital. S orbital has the maximum penetration and the F has the least. We have already seen that. So the ionization enthalpy for magnesium will be great. Consider aluminium, atomic number 13, belongs to the same period. As per the electron configuration, the outermost electron, that is the least bound electron in the case of aluminium, is in the p orbital. The penetration of p orbital electrons is much less than that of s orbital. Therefore, although the nuclear charge of aluminium is more than that of magnesium, and the size of the aluminium atom is smaller than that of magnesium, ionization enthalpy in the case of aluminium is much less than that of magnesium. Because in magnesium, the electron has to be removed from the s orbital, which has more penetration effect than in the case of aluminium, where the electron has to be removed from p subshell, where penetration effect is much less. So, such questions can be asked for the examination. Why is the ionization enthalpy of magnesium with atomic number 12 greater than the ionization enthalpy of aluminium, which has atomic number 13? Fourth one, screening effect of inner shell electrons. In multi-electron atoms, the electrons in the inner shell will shield the outer electrons from the attractive effect of the nucleus. Thereby, the ionization enthalpy in such cases will be much reduced. Now, the fifth one, effect of half-filled and completely filled orbitals. Let us take the example of the ionization enthalpy of beryllium and boron. Beryllium atomic number is 4 and boron the atomic number is 5. Both of them belong to the second period. So, we expect the ionization enthalpy of boron to be greater than that of beryllium. But in reality, we find that the ionization enthalpy of beryllium atomic number 4 is greater than that of boron with atomic number 5. The reason for this anomaly lies in their electronic configuration. For beryllium, the outermost shell 2s is fully filled 2s2. Fully filled outermost electronic configuration gives it more stability. For boron, the outermost shell is 2p. There is only one electron there. It is neither half filled nor completely filled. So its stability is less. Moreover, the electron has to be removed from the s orbital in the case of beryllium and p orbital in the case of boron. So beryllium has more ionization enthalpy than boron. We will see one more example. Ionization enthalpy of nitrogen is greater than that of oxygen. They also belong to the same period, that is second period. Atomic number of oxygen is 8 and that of nitrogen is 7. So oxygen should really have more ionization enthalpy than nitrogen. Now, the electron distribution for nitrogen, the outermost shell is 2p. It has 3 electrons, so it is half filled, so more stable. For oxygen, the nuclear charge is more, but the last shell, 2p, has 4 electrons, so it is neither half filled nor completely filled, so it is less stable. So it is easier to remove electron from oxygen than from nitrogen. So the ionization enthalpy of nitrogen is more than that of oxygen. Now we will sum up the effect of these factors which affect ionization enthalpy. Ionization enthalpy increases with increase in nuclear charge as nuclear attraction increases. This is for across the period. Ionization enthalpy decreases with increase in atomic size. Ionization enthalpy increases with increase in penetration effect. Ionization enthalpy decreases with increasing screening effect. Ionization enthalpy increases with half-filled or completely filled outermost shell configuration. If the video was useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. Press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video. Till then, bye. Take care.